Hi everyone, I am Geetha, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about partial derivatives. Before entering into the partial derivatives, we must know what is derivative. Derivative is nothing but rate of change of one variable with respect to another variable. We have two types of derivatives. One is ordinary derivative, another one is partial derivatives. Ordinary derivative means rate of change of one variable with respect to only one independent variable. For example, velocity, which is defined as the rate of change of displacement with respect to time only. Another one is partial derivatives. Partial derivatives means rate of change of one variable with respect to two or more independent variable. Here, the rate of change of weight with respect to food we have taken and the amount of physical exercise we do. Next, differential equation. Differential equation means involving derivatives. We have two types of differential equation. One is ordinary differential equation, another one is partial differential equation. In this session, we are going to discuss about applications of PDE. In structural analysis, PDEs model the behavior of materials under different loads, helping engineers understand and predict structural response. In fluid dynamics, PDEs, like the Navier-Stokes equation, described fluid flow in engineering applications such as aerodynamics and hydraulic system. In heat transfer, PDEs, such as the heat equation, govern the flow of heat in conductive materials and are used to analyze thermal behavior in engineering system. Electromagnetism, Maxwell's equation, a set of PDEs, model electromagnetic phenomena and are crucial in electrical engineering and communication system. In control system, PDEs are used to develop mathematical models for control system, enabling engineer to design and optimize feedback control strategies. In image and signal processing, PDEs are employed in image denoising, image impending and other image processing tasks to enhance and analyze digital images. In numerical simulations, PDEs are solved numerically using computational method, allowing engineers to simulate and predict the behavior of complex system. In structural optimization, PDEs based optimization techniques are used to optimize engineering design and achieve desired structural performance. Next, this is a partial derivative of f of x comma y. F of x comma y is a function of two variable. Then the first partial derivative of f with respect to x at a point x comma y is defined as dou f by dou x is equal to limit h tends to 0 f of x plus h comma y minus f of x comma y divided by h, provided the limit exists. So which will be partial derivative is denoted by the symbol fx, which is also denoted by fx of x comma y, otherwise we denote it as dou by dou x of f of x comma y. Now we are going to find some first order partial derivatives for given function. Here the given f of x y is xy square plus x square y. Now we are going to find the partial derivative with respect to x. While finding partial derivative with respect to x, you take it as x as a variable and y will be treated as constant here. So fx of x comma y is equal to differentiating x, we get only 1. So 1 into y square plus differentiating x square we get 2x. So plus 2xy, which is nothing but y square plus 2xy. Next, we have to find the partial derivative of f with respect to y. So given function is f of x comma y, which is equal to xy square plus x square y. While differentiating y, we assume x is a constant. So fi of x comma y is equal to x into differentiation of y square is nothing but 2y plus x square into differentiation of y is nothing but 1. So we get 2xy plus x square. Here a few more example. F of x comma y equal to 3x square y plus x into log y. Now we are going to find the derivative of x. Fx is equal to differentiating x square we get 2x. So 3x square means we get which value is equal to 6x into y will be treated as constant. So 6xy plus differentiating x we get 1. So x into log y will be written as plus log y. So next differentiating f with respect to y we get differentiating y we get 3 in 3x square y we are having only 1y. So differentiating y we get 1. So which value equal to 3x square plus x. Differentiation of log is nothing but 1 by y. So fy is equal to 3x square plus x into 1 by y. Next another example is g of x comma y is equal to e to the power of x into y square plus y. Now we are going to find the derivative of gy and gx. So differentiating g with respect to y means we get first differentiating exponential function we get exponential function only. So e to the power of x into y square plus y, again we write e to the power of x into y square plus y. Again differentiating the inner function that will be ex y square plus y with respect to y we get 2 y square differentiation is 2y. So we get 2xy plus 1. So next we are going to find the derivative with respect to x. So gx is equal to exponential function, its derivative is again exponential function. So derivative of e power xy square plus y is again e power x y square plus y. Again differentiating the power we get x into y square. Differentiating x means e to into y square. Y will be treated as constant, so plus it is 0. So gx is equal to y square into e to the power of x y square plus y. Here we are considering the algebraic equation f of x comma y is equal to 3x square y minus 2 plus y. So here fx is equal to 3x square y. Here we are having only one x, that it is x square. In remaining term we don't have x. So differentiating 3x square we get 6 into x. Y will be treated as constant, so it which will be take it as 6xy. Then remaining will be differentiation of constant will be 0. So minus 2, differentiating minus 2 we get 0 and y cube it will be also 0. Next we are finding differentiation with respect to y. Fy is equal to 3x square plus 3y square here. Here we are having one more algebraic equation f of x comma y is equal to 2x plus 3y minus 4. So differentiating the above function with respect to x, here we are having only one x function, that it is 2x. Differentiating x we get 1. So fx is equal to 2. Differentiating 3y minus 4 we get with respect to x mean it will be 0. Next we are finding differentiation of y f with respect to y. So here we are having only 3y only variable, then remaining will be treated as a constant. Differentiating that constant it will be 0. So differentiation with respect to y is equal to 3 here. Next, second order partial derivatives. Second order partial derivative will be denoted as fxx, that is equal to dou square f by dou x square, and fyy that is equal to take it as dou square f by dou y square. Next fxy that is equal to dou square f by dou y into dou x. Fyx that is equal to dou square f by dou x into dou y. Now we are going to find second order partial derivative of the function here. Here we are going to find second order derivatives. So given function is f of x comma y, that is equal to 3x square y plus x into log y. Fx is equal to 6xy plus log y, and fy is equal to 3x square plus x into differentiation of log we get 1 by y. So fy is equal to 3x square plus x into 1 by y. Now we are going to find the double derivative f with respect to x. So fxx is equal to here in fx we are having only one x function, that it is 6xy. So log y will be 0. Differentiating x we get 1. So f double x value is equal to 6y here. Next fyy. In 3x square fy, that is equal to 3x square plus x into 1 by y, we are having only one y function, that it is equal to 1 by y. Differentiation of 1 by y is nothing but minus 1 by y square. So fyy is equal to minus x by y square here. Next we are going to find fxy. Differentiating x with respect to y. So fx is equal to 6xy plus log y. In both the terms we are having y variable. Differentiating 6x into y, we get 1 into 6x plus then differentiation of log y is equal to 1 by y. Next we are going to find fy with respect to x. So fy we are having only one y. Fy with respect to x, here we are having 2x function, that it is 3x square plus x by y. Differentiating 3x square we get 6x. Then differentiation of x into 1 by y, we get 1 by y only. Another example, f of x comma y is equal to 3x minus 2y square. Here first derivative fx is equal to, in the above function we are having only one x term, 3x. Differentiating x we get 1, that it is fx is equal to 3, and fy is equal to, here we are having only one y function, that it is minus 2y square. Differentiating minus 2y square we get minus 4y. Fx next again differentiating x with respect to x, fx is equal to 3, it is constant. Differentiating again we get 0. In fy we are going to find f double y. So differentiation of y is equal to 1, so f double y is equal to minus 4. Again now we are finding fxy. X with respect to y means, here we are having 3 is a constant only, so differentiating constant we get 0. Again we are finding fy with respect to x. In fy we are having y function only, it will be treated as constant, so fyx also 0 here. So in the same manner here we are going to find double derivative of exponential function here. F of x y is equal to e to the power of x y square. Here finding first derivative fx, that is equal to y square into e to the power of x y square, and fy is equal to 2xy into e to the power of x y square. F double x is equal to y power 4 into e to the power of x y square. Fyx is equal to 2y e power x y square into 1 plus x y square. Here fxy is equal to 2y into e to the power of x into y square 1 plus x y square. F double y is equal to 2x e to the power of x y square into 1 plus 2x into y square. Thank you.